So good day everyone. Today I will be discussing to you the two-column proof in triangle congruence. So every proof has in common these things. They all have a diagram, a statement reason table, some given information here, and something that you have to prove. The strategy here is to take that given information, apply what you know already about geometry to that information, and put it together to make a formal argument that proves whatever you're asking you to prove. Which, in this case, is that I need to prove the triangle ABD here is congruent to triangle CBD, and also line segment AD is congruent to line segment CD. So now let's start filling in this table. So our first given here is that line segment BD is perpendicular to line segment AC. Our first statement here is, and our reason is that it is our given. So I have also another given. The line segment BD bisects line segment AC. Our second statement. And our reason here is again, it is our given. So basically, this base AC here is getting cut in half by this vertical line BD. So since it cuts it in half, we know that this line segment AB is going to be congruent to this line segment BC. So let's put it marked here. So our conclusion for this is that line segment AB is congruent to line segment CB. So our reason here is that it is the definition of bisector. And that's what bisectors do. They cut things in half. Now, since line segment BD is perpendicular bisector to line segment AC, we know that angle DBA and angle DBC are right angles. And our reason for that is that perpendicular lines form right angles. And now we can state here that angle DBA is congruent to angle DBC, and our reason is that all right angles are congruent. Now, notice here that I can take this large triangle DCA and split it up into two halves along this line DB. Now, if I split this up into two separate triangles, we notice that they both share that line segment DB. So I'm going to say that line segment DB is congruent to itself line segment DB. So our reason for that is that it is reflexive postulate. And I'm going to go ahead and mark this line segment DB an X. Now with the information that we have so far, we can see that triangle ABD is congruent to triangle CBD. And our reason for that is SAS postulate, or side angle side postulate. And our first side is this, and then our angle here is this one, and our second side for this is this one. Now remember that we wanted to prove that line segment AD and line segment CD were congruent, and those line segments are both within the two triangles were also congruent. So we can say that line segment AD is congruent to line segment CD, and our reason for that is that CPCTC, which means corresponding parts of congruent triangles are congruent. And now we are done with this proof. Don't forget to put QAD in the last part. So that would be all. Thank you.